Let's have a look at question 1 in this video. So we have research based on the food quality and preference. Now, what do we want to know here? The researchers got 61 visitors to participate in a small experiment. They had 2 yogurt products. The first one was organic and the other one was regular. Now, this is the table with the amounts people are willing to pay in dollars for the first yogurt and the second yogurt. Assume that the sample was a simple random sample from the population. Based on that, we have the sample data, so the mean, the standard deviation. We're going to discuss those in a second. We want to draw the 90% confidence interval for the amount that the visitors are willing to pay for the regular yogurt. So we're dealing with the second column over here. So what's the intuition? We want to know whether there is an effect from labeling the yogurt differently, because if it's organic, people will assume it's better quality, so they're probably willing to pay more. But we want to know whether that's true or not. Based on this, we have sample, right? We have several people, 61 visitors, and they tasted both types of yogurt. And in this case, we have data based on this sample. So we have the mean of the sample and the standard deviation of the sample. We're dealing now with the second yogurt over here. So we have the data, the sample mean, the sample standard deviation. How do we compute the confidence interval? Well, we know that the confidence interval is going to give us a range of values that will contain the mean, the average willingness to pay for the entire population for the second yogurt with a probability of 90%. So let's do so. We'll calculate the confidence interval here for the mean of the second group based on the sample mean and all the other data that we have at our hand. So that's going to be x bar of the second group plus minus the critical value of the t distribution. Now, why do we use the t distribution? Although we have 61 visitors, it would not be much of a difference if we use the z critical value. They're not that far from each other, but for the sake of being accurate, because we have to be accurate for our answer key to be either true or false, we will use the t distribution, the t critical value, because we have sample standard deviation. If we had the population standard deviation, we would go for the z critical value. Now, what would be the t critical value here? That's going to be the t critical value with an upper tail p probability, so with an upper tail of 0.05. Since this is a 90% confidence interval, we must have 5% on every tail. So that's going to be 0.05 over here. And the degrees of freedom are going to be the number of observations minus 1, multiplied with the sample standard deviation of the second group divided by square root of n. Let me change colors for that. We will have the sample standard deviation of the second group over square root of n. Now it's a matter of math to substitute some values, so let's do so. Let me just zoom out, get more space. We go over here below, we have everything, we can just do the math. So we will have the following. We will have the sample mean equal to 1.14, so we substitute that, 1.14 plus minus the t critical value. We can find it in the t distribution by looking at the 5% upper tail probability, and the degrees of freedom are going to be 61 minus 1, so that's going to be 60 over here, and that t critical value is going to be 1.671 times the standard deviation, which we have as 2.17, so we write it like that, 2.17 divided by square root of n, which is square root of 61. Now, if you solve the math over here, we will get the values as in the answer key. We will get 0.68 until 1.60. And by the way, this should be square brackets. I don't know why they put it as round brackets. Maybe they consider this as a wrong answer. I don't know. Maybe it's a typo. Anyway, if that's the case, then this answer would be true, and we are done.